Hello, welcome back to Design Hub. In this video, we will learn about preliminary process piping components. Here is a small portion of the process piping model which shows different components. First, let's see what is a pipe. Pipes are tubular products that are used to transport liquids. Pipe sizes are generally identified as nominal bore, NB, or nominal pipe size, NPS, or diameter nominal, DN. From a dimensional point of view, the pipe is not equal to a tube. The purpose of a pipe is to transport liquids, gases, and other substances. They are intended for certain pressure ratings and are commonly used in industries including oil and gas, chemical processing, and HVAC systems. Tubes are utilized in structural applications, heat exchangers, and precision operations that require high strength, an accurate outer diameter, OD, and aesthetic appeal. The measurement of pipes is measured using the nominal pipe size, NPS, or diameter nominal, DN, which refers to the interior diameter, ID, for flow capacity. The schedule number specifies wall thickness. Tube dimensions are determined by its outer diameter, OD, and wall thickness. This exact measurement enables optimum fit in structural and mechanical applications. The codes used for pipe selection are ASME B36.10, welded and seamless wrought steel pipes. ASME B36.9, stainless steel pipes. Here you can see the classification of pipe. We will learn about some types of pipes and then go through them in detail in upcoming videos. Let's see, circular pipes that have a hollow part and no joints or seams are known as seamless pipes. Electric fusion welded, EFW. This process involves joining single or double longitudinal pipes together using a manual or automatic electric arc welder such that the pipes coalesce inside the prefabricated tube. Steel sheets are cold formed into cylinders to create electric resistance welded, ERW, pipe. The steel is then heated to a point where the edges are pressed together to form a bond without the need for welding filler material by passing current between the two edges of the steel. They are created by using a mandrel to extrude a solid, almost molten steel rod known as a billet into a hollow form. Firstly, they heat the billet. Then shape the billet into a circular, oblong mold that is pierced and hollowed out. Then extend the mold by drawing it through a mandrel rod while it's still hot. Utilizing cold rolling, cold drawing, or pilfering, give the tubing more shape. Now, we will learn about the wall thickness of a pipe. It is described by a dimensionless number called a schedule number, sometimes referred to as a pipe schedule. This guide number is derived using a formula that takes into account the working pressure, nominal size, and pipe wall material of the pipe. Schedule numbers rise in proportion to wall thickness. However, multiple pipe sizes might utilize the same schedule number, leading to varying wall thicknesses. Let's see about the schedule number formula, where the service pressure is in psi. Also, the allowable stress is in psi. For example, we have two pipe of same size and different schedule. That is 4-inch NPS schedule 80 pipe and 4-inch NPS schedule 160 pipe. Usage of schedule number is that the different pipe system usage codes specify varying thicknesses for various applications and uses. Numerous codes, including IBR, ASME B31.1, and B31.3, include formulas to determine the minimum wall thickness permitted based on the material pressure inside the pipe. Let's learn about preliminary components of process piping. A piping system is an assembly of various components put together with a proper method of joints, functionally to transport fluid from its source to destination. The different components put together are defined as piping components. They are designed for withstanding the operating and design conditions specified in the process parameters. Each component used in piping systems are specified in piping specification. Pipe system components used are 1. Pipe. 2. Pipe fittings. 3. Flanges. 4. Gaskets. 5. Bolting. 6. Valves. 7. Specialties. One by one we will learn all about the process piping components. Once again, let's see what is a pipe, the fundamental element of any piping system, available in various materials, for example, steel, copper, plastic, and sizes to suit different applications. Usually, pipe lengths are not precisely cut to length when they are delivered from the factory. Now, Important part is that the typical length of pipe that are manufactured. It is divided in two parts. One is single random, in which pipes are being cut and range between 4.8 to 7 meters. Another is double random, in which pipes are being cut and range between 11 to 13 meters. Also, pipe ends are important for the required application. First, we have plain end, in which pipe are finely cut perpendicular to its center axis at both the ends. Plain end pipes are typically used in conjunction with socket weld fittings and flanges as well as slip-on flanges. Fillet welding is needed for both styles at the base of the fitting or flange and on one or both of the fittings or flanges sides. In order to allow for thermal expansion during welding, the plain end will, if applicable, normally be positioned 1/8 of an inch from where the pipe sits. They are therefore perfect for piping systems with small diameters. Uses and considerations for threaded end pipe is that they have an excellent seal and are typically used for pipes with a nominal size of 3 inches or less. The National Pipe Thread, NPT, standard is used by most pipes. The term bevel end refers to a pipe end that has been constructed at a certain angle. The procedure of beveling a pipe or tube entails forming an angle between the end and a plane that is perpendicular to the surface. The most popular bevel forms are compound and V-shaped bevels, and 37.5 degrees is the typical welding angle. The fitting end that is intended to be assembled into another fitting is referred to as the spigot. A fitting spigot end and pipe have the same outer diameter. Applications for socket end pipes and spigots include the following: sewer networks. In sewage applications, spigot and socket joints are employed to maintain waterproof systems. By enlarging the wall of one end of the pipe, a seal is produced between the male spigot and the female socket, forming the joint. When the pipes are connected, the rubber ring at the spigot end contracts and rolls away. Drinkable water. Potable water is often transmitted and distributed via ductile iron pipes including socket joints and spigots. Now, the second preliminary process component is fittings, which contains elbow or bends, tees, reducers, and couplings, eyelets, bends, cross, union, cap, etc. Fittings are mainly used to connect pipes together of same or different sizes using reducers, change direction of flow using respective elbows, or transfer fluid to some tank using tee from main branch. The term 90 bends or 90 elbows refers to elbows that are 90 degrees. There are two types of 90-degree elbows: short radius, SR, and long radius, LR. The elbows differ in their curvature radius. In an LR elbow, the curvature radius is 1.5 times the pipe diameter, whereas in an SR elbow, it is equal to the pipe diameter. Because of their strength, resilience to abrasion, and longevity, 90-degree elbows are well suited for extended usage in harsh industrial environments. Numerous materials, such as carbon steel, stainless steel, alloy steel, duplex, super duplex, copper nickel, and nickel alloys, can be used to make them. Also, there is 45-degree elbow, which only comes in one variant that is long radius. The name of this fitting comes from its resemblance to the letter T. It is a 3-outlet fitting used to make perpendicular connections to a pipe. Here are two fundamental piping system fittings that are utilized to transfer fluid to another site or change direction. A straight T is referred to as such, while a reducing T is another. Let's attach these T's to a header pipe. All three exits on a straight T have the same nominal pipe size. The branch of a decreasing T is thinner than the header's line size. A note defining the header size and branch size, 6x4, as illustrated, must be attached to a branch that is 6 inches or less. This is necessary since all pipe lines 6 inches and smaller are drawn as single lines, making it challenging to discern between pipe diameter sizes. Take note that installing the fitting within the header requires 3 welds to be made on the weld T. The weld dot on the 6 and smaller branch exit on the reducing T should catch your notice in particular. Reducers are classified into two types: concentric reducers and eccentric reducers. First, concentric reducers. Cone-shaped reducers that reduce a pipe's diameter while maintaining its centerline. They can be made of many materials, such as carbon steel, stainless steel, and copper. Concentric reducers can also be butt weld fittings, which are welded to the pipe to provide a secure connection. Concentric reducers should be used in vertical pipelines. Second, eccentric reducers. It is used on the suction side of pumps to keep air from becoming trapped in the tube. Eccentric reducers can also aid in reducing turbulence and vibration produced by changes in direction or size in a piping system. The two reducers have significantly different features. The concentric reducer keeps the same centerline at both the large and small ends of the fitting. The eccentric reducer, on the other hand, features offset centerlines that result in a flat surface on either the top or bottom of the fitting, depending on how the fitting is rolled before welding. The offset can be found by deducting a small outside diameter from a bigger one and dividing it by 2. Where drainage is required, eccentric reducers should be fitted with the flat plane at the bottom. Eccentric reducers should be put on centrifugal pumps horizontal discharge with the flat pane down. We will learn about other fitting in the next video. Until then, learn and advance. Peace.